Okay, in this question, we are doing some optimisation. So we have a gardener and they want to put a fence, a rectangular fence, along an already existing back fence so that only 3 new sides of fencing are required, and that total material is 16 metres. So always start with drawing a picture. So that's the fence that already exists, so we don't need any material for this fence. And then we want a rectangular fence, and that's going to be 16 metres. Now we want the largest possible area, so we want this area in here to be as big as possible. So let's label these. We'll go with just x and y, and we already have one equation, which is 2x plus y can't be greater than 16 metres. What we're after is actually the area, which is x times y. And we want this area to be the biggest possible number. So we have 2 variables. We need to eliminate one of the variables so that we can just work with one. So let's rearrange this and work out what y is equal to. So 16 minus 2x. So now we have what y is equal to. We can come back up here and we can replace y with the 16 minus 2x. And if we expand this out, we end up with 16x minus 2x squared. Now, optimisation involves finding a maximum or a minimum, depending on the question. This one, we want the largest possible area, so we're after a maximum. And if you think about what this graph would look like, it's going to be an upturned U because it's a negative x squared graph. So we want to know what is this maximum value here. Now, to find maximum and minimum values or turning points, as we know them, we're looking for the derivative. So we're going to find the derivative of a. 16x drives to 16, and then we drop our power, 2 times 2, 4x. So now we have a derivative. We want a stationary point or turning point, maximum value, when the derivative is equal to 0. Rearranging this, we find that x would be equal to 4. Now, if we go back over to this equation, we can see that by substituting 4 in for x, we would have 8 plus y equals 16, so y is equal to 8. All right, now the question didn't ask about how big x and y was, it asked for the maximum area. So we would go back into our original equation and we would, of x by y, and we would have 4 by 8, and 32 metres squared would be our maximum. Now you should always verify this even if the question doesn't say it. So to verify, we can just check 2 ways. We can check that the a derivative for x equals 3.9 and the a derivative x equals 4.1. All right, so before this, when we substitute 3.9 into the derived equation, this one up here, we get a positive value. And when we substitute 4.1 in, we get a negative value, which means that the graph before the turning point is positive and after. That's one way of pointing out that this is definitely a maximum. So we have achieved a maximum. And another way to prove it is just to check. So if x was 4 and y is 8, then area is 32. If x was just smaller than that, 3.9, y would be 8.2, substituting it into the original perimeter equation, and the area is 31.98, so smaller, so 32 is definitely big. And if we go the other way, 4.1, y would have been 7.8, and the area of that one would have been 31.98. So we have indeed found the maximum area for this fence.